everyone. I am
Yes,
Bosa
ma'am.
Jiang from the Department of Electronic Engineering, Yangon Technological University.
Ma'am, can you click on full screen? Yes, ma'am.
Okay.
Good to go, ma'am. Please continue.
Yes. And so today I will present about implementation of weather sensor interface system based on pre-programmable gate array FPGA. So as an outline of presentation, introduction about sample diagram, research methodology, hardware component, block diagram or sensor design, final state machine, and simulation result, and results, and so on. And what is FPGA? FPGA is a pre-programmable gate array. It's an integrated circuit that can be configured by the user to emulate any digital circuit as long as they are in resources. And it can be seen as an array of configurable logic block connected through programmable interconnect. And FPGA configuration is generally specified using a hardware description language HDL. And this is the sample diagram. It is a BME280 sensor and Nazivo DDR both connected with SPI. So the analog signal is coming to the SPI interface and it is changed to the digital signal and passed through the Nazivo DDR port and is connected with this pin. As a research methodology, the main communication is SPI. Serial preferred interface is a synchronous serial communication interface specification use of short distance communication. In my research, I will use 4-wire interface and it is a clock, a chiplet, MOSI, and MISO. And the FSM, final state machine, is used to perform a predetermined sequence for the system. And the VHDL, the configuration has been described using VHDL. So how to implement SPI master on FPGA? The SCLK input frequency is 2 Hz, that is divided by clock divider in VHDL design because the input frequency of FPGA port is 100 MHz. Re-register address are imported by the switches and the data is shifted in the data transfer state or FSM. And when CS is 0 in idle state, MSB or data register is shifted to MOSI at data transfer state, and CS is 1 at store state. The MOSI is output of FPGA port and input to environmental sensor. And using oscilloscope, the serial sensor data output MISO is displayed. As a result, the hazard decimal value of temperature data are displayed on 7 segments of FPGA port. So as a hardware component, Nazivo DDR at 7 FPGA port, I will use the board is a complete ready-to-use digital circuit development platform and with a large high-capacity FPGA, general external memory, and collection of USB, Ethernet, and other ports. And it also can host design ranging from industry combination circuit to perform embedded processors. And that is BME280 environmental sensor. The sensor is a digital humidity, pressure, and temperature sensor, and it has small dimension, low power consumption, high precision, and stability, and is to achieve high performance in all applications requiring humidity and pressure measurement. As a specification, operation voltage is 3.3 volt to 5 volt, and interface is both I2C and SPI. Temperature range is -40 to 85 degrees Celsius. Humidity range is 0 to 100% RH, and pressure range is 300 to 1100 hectopascal. This is the block diagram of sensor design. Firstly, initialize BME280 sensor, and then retrimming parameter and pressure data 20 bit, read temperature data 20 bit, and humidity data 60 bit. This is the main diagram of FSM state machine. At the idle state, if load is 1, go to control right 1, count is reached 31, go to stop 1. And then in control right state, one count is reached, count 7, and it's go to data reach state, and then count one count is 27, is go to start 2, and the calculator state, the data from sensor 20 bit is compensated with calibration data, and then the result is the Azure temperature value, and then start 3 state, and if load is 0, will go to idle state. So this is the simulation results of sensor data by Fvge design. So in this state, at idle state initially 0, and then control right state, the control register 32 bit is shifted to MOSI, and then store 1 state, and the control right state 8 bit or data register is go to MOSI. And then data read state, the sensor from data is reader and results from MISO. And then calculate state, the 20-bit of sensor data and calculated with calibration data. This is the indoor measurement register address for SPI, right? Pressure over sampling is 1, temperature over sampling 1, and sensor mode is 4 mode. T standby is set to 1000 millisecond, and theta coefficient is 0.5. So pressure and temperature over sampling is 001, sensor 4 mode is 01, and T standby is 101, and theta coefficient is 0. So the result of 32-bit control register is as so. This is the calibration data from BME280 sensor for temperature, pressure, and humidity. This data cannot be changed. This is the results of calibration data from sensor by using Fpga board. The data register is command by switches, and the results were displayed in LED. This is the results of sensor data from oscilloscope, SCLK, CS, MOSI, and MISO. We register address is sent from switches or Fvge board and as a sensor input. This is the results of Azure sensor data with Fpga board. First figure is the 20-bit of sensor show in hexadecimal value, and then the second figure is room temperature. Room temperature value at in hexadecimal value is 29.76 degrees Celsius, and then the sensor is heated. The temperature is increased 34.93 degrees Celsius. As a conclusion, the design based on using Fpga for the hardware implementation of the SPI for remote monitoring, and the BME280 sensor need control register to measure temperature by using Fpga. The controller circuit has been described the results of temperature data using VHDL. The digital raw data from sensor is calculated with calibration data. The FSM design has been simulated using Xilinx Vivato software tools. This is the references. And thanks for your attention.
Yes, ma'am. Thank you so much for this presentation on weather sensor interface system.